sense. So now back to this. So the 3 squared is going to be a 9. Then we also square our denominator to get 25. So when we have a fraction squared, it just means both terms are going to get squared. So 3 squared divided by 5 squared is just going to give you 9 over 25. So number 18, same thing. Every term in here gets squared. So this would become 2 squared, a to the 10th over b to the 14th. All right, so powers to a power. 2 times 1 is 2. 2 times 5 is 10. 2 times 7 is 14. So each of these now got raised to the power of 2. And then I probably would now finally write this as a 4, a to the 10th, over a b to the 14th. All right. All right, so now 17, yeah, let's just keep doing it that way. This 3 has a power of 1. We don't have to write it in normally, but I'm going to. So I'm going to do 3 times the 1, so that's going to be 3 to the 3. And then the negative 4 gets raised to the power of 3, so that's going to be a to a negative 12. And then the 3 and the 7 should give me b to the 21st. All right, so to now simplify this, first thing I'm going to do is 3 cubed, so that's just 3 times 3 times 3, so that should give us 27. And then if you notice, this a has a negative exponent. Any negative exponent means we just want the reciprocal of that number. So if the a is currently in the numerator, the reciprocal means we want to put the a into our denominator, and then that changes our negative 12 into a positive 12. So notice how a is in the numerator at the beginning, denominator at the end. If you look at the b, notice how b is in your denominator, but it has a positive exponent. That means we don't want to move that. We're going to keep that right where it was. So the b to the 21st stays into our denominator. So this final answer would be 27. And then in the denominator, a to the 12th, b to the 21st. All right. Yeah, Ahmed?
I have a question.
Yeah, go ahead.
What happens if the a is a positive? Would the a stay in the same denominator or the numerator?
Yep. If you have a positive exponent, we're not moving it. All right. So your question, let's say I gave you a to a negative 2, b to the 4th over c to the negative 6, d to the 9th. The 2 that have negative exponents, this guy here, that needs to get flipped. So I'm going to put the a into the denominator. And then this also has a negative exponent, so that c needs to go into my numerator. Those are the only 2 that get moved. Notice how the b had a positive exponent, so it would stay on top. The d had a positive exponent, so he's going to stay into the denominator. We only flip the ones that have a negative exponent. All right?
Okay, thank you.
Yep. All right, so now last one, and then we'll just start cranking out a bunch of these, and we'll get some practice at it. Same idea. This whole thing is raised to the negative 6. So if I have a power on all of them raised to the power, this is a product. So I'm going to do a to the 12th. And then the negative 6 and the negative 5 should give me b to the 30th, all divided by, and then the negative 6 and the negative 11 should give me a positive 66. So now to kind of Ahmed's question, notice how there are no negative exponents there? That means we don't change anything. That's it. That's our final answer. We would just get a to the 12th, b to the 30th, all divided by c to the 66th. All right. Those are all of your rules. Some of them are just compounds of each other. And I will just do a bunch of these. Do 1 and 2 real quick. As simple and as quick as they are, we just got to kind of remember, what are we doing? Are we adding, subtracting, multiplying? What do we do with those exponents? So try 1 and 2 real quick. All right, and our rule, when we multiply like terms, we should be adding exponents. So that would just be x to the 11th. All right. Number 2, we just did a bunch of them. If you have a power, which we do, and then it is getting raised to a different power, which we do, so the 8, x to the 8th is getting raised to the power of 3, that's when you actually multiply. So we would just get x to the 24th. Okay. 3, we have a negative exponent. So for the sake of, normally if I just have the number 6, we don't ever show it. We don't ever need to. Or if you just have an x, we don't ever really need to show it. But there is a 1 underneath it. We can always write any single term as a fraction if we put a 1 under it. So for number 3, that's what I'm going to do. I'm just going to write this as over a 1. And then that negative exponent, it's just easier to see that it's currently in the numerator. So for us to turn that into a positive exponent, we want to put it into our denominator. So the x to the negative 3 in the numerator becomes an x to the positive 3 in our denominator. And then the new exponent is just the 1. All right. Then 4, as easy as it gets. Anything to the 0 power is a 1. There's absolutely no work there. All right. And then our final basic rule, when I divide like terms, so x to the 8th divided by x cubed, we subtract exponents. I'm going to actually kind of show this. We always do the numerator exponent minus the denominator exponent. So 8 minus the 3 is x to the 5th. So that's our answer. The reason I'm showing that is so we understand how you can handle 8, because there's a couple, or I'm sorry, number 6. There's a couple different routes we could take with number 6. We could do our subtraction and just do the 3, take away the 8, which would then give us an exponent of a negative 5. But if you look at your directions, these would be the directions that I always give you. Final answers should not contain negative exponents. So right now we don't want to leave this as our final answer because it has a negative exponent. So what we would want to do is the same thing that we would have done up here. Understand that this currently has a denominator of 1. That x to the negative 5 needs to get placed into the denominator in order to make that exponent positive. So our final answer is the 1 over x to the 5th power. That is perfectly valid. Absolutely something that you could do. Long term, that's not the way I'm going to probably approach this. I would hope as we move forward, we can look at this guy right away and just say that we have an x to the 5th in our denominator. Because if you really understand what this is saying, let me create a little space here. What you really understand this is saying, I have 3 x's on top and I have 8 on the bottom. 1, 2, 3, 4, 5, 6, 7, and then 8. So if I have 3 on top, 8 on the bottom, wouldn't 3 of them completely cancel, leaving me 5 x's on the bottom? Versus this one, think about what this one is. I have 8 x's on top. I have 3 on the bottom. So if I know the 5 extra ones are on the top, don't I just end up with here 5 x's on the top, but here I get 5 x's on the bottom. All right. So to me, that's a little easier. It's a little bit quicker, but it's really up to you how you want to be able to do those. So real quick, let me show you another one of those just to make sense of that. Let's say I gave you x to the 4th divided by an x to the 7th. You could, if you want, say this is x to the 4 minus 7 and write that as a negative exponent. But then what you have to understand is we don't want that negative exponent, so the x to the negative 3 gets put into the denominator, and that's how we change it to a positive exponent. Or if you just understand by looking at this, don't I have 3 more x's in my denominator? So the 4's are going to cancel, and I would just end up with 3 extra x's in the denominator, and I still get that 1 over x cubed. Okay? So with a lot of these, the order of operations here are fluid. You can actually do these in a lot of different orders. It's not like a lot of the math that we've done. So that's something to just kind of be careful of. All right, so now number 7. Let me get rid of this. Oops. The first one where you now have a combination of some rules. So like right from the beginning, there's probably 3 different routes you could take here and get the same exact answer. All right. So the way I'm going to do this, I'm going to do my numerator first. So look at your denominator. There's not a whole lot we can do in our denominator. So let's just rewrite the denominator again as x cubed. But if this was its standalone problem right here, so if I gave you x to the 8th times x to the -2, tell me what we think we would get for that exponent. It'd be x to the what? Write down what you think that would be. All right, what we hopefully have, this is our very first rule here. When I'm multiplying like terms, which I'm doing here, we add the exponents. That's what's happening here. I'm multiplying like terms, so I should add those exponents. And an 8 and a -2 add to be a 6. All right. From there, now we're dividing. So now we've got to go to our rules that we just did in number 5 and 6. When I divide like terms, I'm subtracting. So notice how the difference between a 6 and a 3 is 3. That's the difference in those. Don't we have 3 more of them in my numerator? So if we cancel out 3 sets, I should still have x to the 3 in my numerator. And then that's our final answer. All right. Just to show there's a different way, here's another route we could take. And again, it's totally up to you. It's whichever you see easiest. Let's do this guy first. Doesn't that mean I could put that into my denominator and make it positive? So the x to the 8th I'm going to rewrite. The x cubed I'm going to rewrite. But this guy means I'm supposed to put it into the denominator. From there, I get x to the 8th, and then now I'm multiplying an x cubed and an x to the 2nd. That should be an x to the 5th. And then does an 8 minus 5 still leave me with a power of 3 to give me an x cubed? All right, so a lot of different routes you could take with these. So with that, try number 8, whichever route you think you would do in number 8. See what we get for our final answer there. All right. Anybody feeling good about this one? Yeah, Cam, what do you think? Cam, what did you do first?
First I added 8 and 7.
Good.
15.
Good. So he just simplified the numerator first, and he got x to the 15th, which is good. And then that would have been x divided by x to the what?
To the 9th.
Good. So when we multiply like terms, which is what we're doing in the numerator and denominator, you add those exponents. And then now if I have an x to the 15 divided by x to the 9th, that should give us what, Cam?
X to the 6th.
Good. X to the 6th power. All right, perfect. Okay. All right, the next one. Now we're just going to be multiplying. So notice how we're multiplying. Don't be thrown off now with numbers. We are not changing the rules of math. A -4 getting multiplied by a 7 is still a -28. All right, that is not changing. Now we, though, have to multiply our like terms still. So now I need to take x to the 12th, and I need to multiply it by an x to the 5th. So when we multiply like terms, Cam just did it, we add the exponents. So you do 12 and a -5. We need to add those together. Should leave us with 12 or 7 x's. So an x to the 7th. From there, let me find another color here. Let's go blue again. If I do a y to the 8th and a y to the 10th, and I multiply those together, add those exponents, should give you y to the 18th. All right. All right, 10, adding another layer to number 10. So as we start adding these should get progressively harder and open up more opportunities to make a little mistake here. So what I'm going to have you do first, so don't do this on yours, but let's pretend this wasn't there for right now. We'll reintroduce that in a minute. Just simplify that guy. See what you think this would become. here's hopefully what we have. This negative 5 has a power of 1. Okay, so what we would have is a negative 5 now squared. We're just multiplying. Exponents to the exponents, you multiply. A 2 times a 6 is a 12, so we get x to the 12th. And then the 2 and the 3 should give us a y to the 6th. So completely simplified, that should be 25, x to the 12th, y to the 6th. All right. But then what we now have to do, because we can't just ignore this because obviously it's part of the problem, we now need to take this one and see what that one simplifies to be. All right, so same process. The 2 has a power of 1 right now. So I do 3 times 1 to get 2 cubed. The x has a power of 1. So again, a 1 times a 3 is 3, so x cubed. And then 3 times 9 is 27. So if I now simplify that, 2 cubed is 2 times 2 times 2. So that should be an 8. And then x cubed, y to the 27th.
Hey, Mr. Pena?
Yeah.
What in a negative 5 squared? Because I put it in my calculator.
All right.
I got a negative 25.
So be very careful how you now do that. So there's a difference between this guy and this guy. So yeah, know how to plug this into your calculator and which one we're going to do, because the calculator will fool you a little bit. Put parentheses around that now, Cam. So do a parentheses negative 5, close it, and then square it.
Ah, okay. Yeah, I got a regular 25.
Okay, because this should give you a regular 25, like you said. This actually is only going to give you a negative 25, because when it's written like this, the only thing that's getting squared is the 5. So this actually just gets dropped down. And then 5 squared is 25. But if I put it into parentheses, this negative isn't the negative part of what's getting squared now.
Yeah.
So if we look at our problem, isn't the negative inside of the parentheses? So the negative is also going to get squared and get a negative times a negative.
Okay.
All right. So yeah, good question. All right. From there, our final answer, when we now multiply all of these things together, if I did 8 times 25, that should be 200. If we then go to our x's, I have an x to the 12th and an x cubed. When we multiply like terms, we add the exponents. So that should be a 15. And then the same with our y's. This color. If we have a y to the 6th and a y to the 27th, when we multiply like terms, you add the exponents. It should give you 2, so y to the 33rd. All right. No negative exponents. That means everything is good. All right. 11. 11 I think we can do. Try 11. See what we get. All right, let's see what we got here. The numbers behave normally, so don't start being creative and start making stuff up. 33 divided by 11 is still just a 3. All right, so we were not subtracting anything there. You just do your normal 33 divided by 11. When I now take an x to the 25th and I divide that by an x to the 8th, when we divide like terms, you subtract the exponents. So that should be 17, and I had more on top. So it should be an x to the 17th in my numerator. And then our last set of like terms that we're going to be dividing is this y to the 6th. And then this is a y to the 1st. So just again, know there's a 1 there. So 6 minus 1 is a 5. So that should be our answer. All right, 3x to the 16th, y to the 5th. All right. All right, 12, same thing. See what you think for number 12. See what you get for that answer. Three parts: the numbers, the x's, and the y's. Two of the three should make you think a little bit. A little hard, a little bit harder than maybe what you think. All right, see what we got here. So the nice thing about number 11, 33 divided by 11 is a nice number. It's just 3, so we can just write that. When I do a 36 and a 30, those do not go into each other nicely. I don't want this as a decimal. So if you get whatever that is, what is that? 980, so like 1.125, I don't want to see 1.125. Okay, we want to reduce this down as a fraction. So the number that divides the biggest number, greatest common factor between a 36 and a 30 should have been 6. So we're going to divide each of them by 6. So 36 divided by 6 is 6. 30 divided by 6 is a 5. I guess it was 1.2 then, wasn't it? The decimal you should have gotten. Okay, so this becomes a 6 in the numerator and a 5 in our denominator, 6/5. When we move along to the next set of like terms, so now I'm going to do x to the 11th and an x to the 5th. We subtract those. An 11 and a 5 have a difference of 6. Since we have more of them in the numerator, that means the extra 6 would be left over in the numerator. So I get x to the 6th in the numerator. And then the last set of like terms are the y's. So between a 4 and a 10, the difference is 6. But you want to ask yourself, where were the extra 6 going to be? So since I have more in my denominator, those extra 6 should have ended up as a y to the 6th in the denominator. Okay? So that's our final answer, 6x to the 6th over 5y to the 6th. All right? All right, I'm going to have you do 14 next. Try 14 real quick. Just simplify this as much as you can. All right, what you're hopefully noticing, are there any like terms whatsoever? No, there's no common set of numbers, no common x's, no common y's, no common z's. So all you're really doing is ensuring that we don't have any negative exponents. So this is really kind of getting to Ahmed's question earlier in the period. Anything with a negative exponent, we need to flip it. So if I look at 8 and z, notice how those don't have negative exponents. So when I go to write that answer, the 8 better stay on top, the z better stay on the bottom, because their exponents were positive. But if I look at the other two terms, if I can get this up. So if I look at this guy and this guy, notice how they did have negative exponents. Those are the two that need to get flipped. All right, so the x to the negative 8th becomes an x to the positive 8 if I put it into my denominator. And the y to the negative 4 that's currently negative in the denominator, if I put it into my numerator, it magically becomes positive. The negative exponents mean we want the reciprocal of whatever that term would be, which basically just means flip the numerator or denominator. All right. Okay, let's try to get 13 done, because the rest I think we're good from there. So here's what we want to do in 13. Notice how we have this big parentheses, kind of like your old order of operations. What I want you to do real quick is, let's pretend the 4 isn't there, so don't cross that out on yours. Just tell me what the inside would become. So simplify the inside. Now we do have like terms, the negative 5 and the 15. We have 2 sets of x's and we have 2 y's. So just simplify the inside and then we'll deal with the 4 at the end. So when we do those numbers, you have a negative 5 divided by a 15. The greatest common factor of those would have been a 5. So if I did a negative 5 divided by 5, that should leave me with a negative 1 in the numerator. And then 15 divided by 5 should give me a 3 in my denominator. So it just reduces to be a 1/3, and it would be a negative 1/3. The x's, hopefully we're good with. If I look at x to the 11th divided by x cubed, I'm subtracting those. That's 8. I have more in the numerator, so those extra 8 would be in the numerator as x to the 8th. And then the last set are the y's. 7 minus 6 is a 1, and I had more in my numerator, so it's going to be a y to the 1. Once the inside is now simplified, now we got to raise everything to the power of 4. So what we're going to end up with here is a negative 1 to the 4th. And then that 8 and the 4 make 32. And then the 4 and the 1 would be y to the 4th. And then in my denominator, I get a 3 to the 4th. So every term gets raised to the 4th power. So negative 1 to the 4th. And then the 8 and the 4 multiply together, they give you 32. All right, 1 and 4 multiply together, give you a 4. So last step then, negative 1 to the power of 4. So the reason a negative 1 squared is a positive 1 is because this guy right here is an even exponent. So if I give you a negative 1 to any even power, 2, 4, 6, those should always end up giving us a positive 1. That's what we have here. Negative 1 to the power of 4 is a 1. And then the x to the 32, y to the 4th, we don't change. And then just know 3 to the 4th power is 3 times 3 times 3 times 3. You have a calculator, okay, at your disposal, at the end on your phone, whatever. So don't be afraid to use it. If you have to do it all out, 3 times 3 would have given us 9. 3 times this next 9 would have given us 27. And then 27 times 3 should give you 81. All right. So this would be our final answer.
Sorry on chocolate. I think it's time to go. It's 10:39.
Yes, you are correct. Real quick, just remember the homework. You can find it underneath assignments, or you can find it in module 3 right here where it says the homework. All right. So that'll be due tomorrow night. If you have any questions on it at the beginning of period tomorrow, just let me know. All right. Okay. See you guys. Have a good night.